This is the fourth lesson on the normal distribution, and today we're going to be looking at something called the standard normal distribution. Years ago, before we had these fancy calculators, you used to have to use tables to find the areas under a normal distribution curve, or to find the probabilities under a normal distribution curve. And if you think about it, there are loads of different means we could have. There are loads of different variances or standard deviations we could have. And that would lead to lots and lots and lots of different tables. So we had something called a standard normal distribution, and basically you used to look up a table, but this table was where the mean was 0 and the variance was 1 squared, which meant that the standard deviation was 1. And that's what these tables or table had, which meant you had to do like a little bit of extra working out if you wanted to change the mean and you wanted to change the standard deviation. And when you have a mean of 0 and a variance of 1 squared, we call this the standard normal distribution. Now, we don't really need to use tables anymore, but it's really useful to be able to know what this is all about and how to use it. And where it really comes into its own is where you get questions where you need to work out what the mean is, or you need to work out what the standard deviation and variance is, because there's no mode on your calculator that lets you work backwards that way if the mean is unknown or the variance is unknown. So there's a couple of things that we need to do. So the first thing I just need to tell you, we've been using x, haven't we, like for a normal distribution with these bits of information. When we have a standard normal distribution, we'll use the letter z, yeah, so that we know we're talking about the standard normal distribution, yeah. So this is what we're going to have here. This is important. So we use z. Whenever you see somebody use z, you know that they're referring to the standard normal distribution, and you can see it up here highlighted. There's a nice drawing of a normal distribution there, and you can see some other information here. This Greek letter phi, T-H-I, phi of A equals Z is less than A. Now what does that all mean? Right, okay. We talked about the area under the graph, and we refer to it as a percentage or a decimal. The proper symbol is this Greek letter phi, and basically what this means here, phi of A, and A is in bracket, it means the area from the left up to A. So if you see this, phi of Z, like that, I'll just use a different letter. So this is a Greek letter, phi, T-H-I. Phi of Z, what that basically means, it means the area up to Z from the left, or the left tail, yeah, which is what our calculator gave us. So we refer to this area here as phi of Z, and again, because we're using Z, it means that we're referring to this standard normal distribution that has a mean of 1 and a variance of 1 squared. Now you might be thinking, well, okay, I've got this standard normal normal distribution with a mean of 0 and a variance of 1 squared. How can I sort of convert between that and a different type of question where I've got a different mean and a different standard deviation? Well, if x stands for any type of normal distribution, okay, so this is one where we've got any mean and any variance. If I take that value of x somewhere on the axis, so somewhere along here, and it's a different mean to 0, let's say, You know, we've got a mean there and a different standard deviation. If I want to convert an x value, yeah, to a z value, so a non-standard value, so I'll put non-standard here, to a standardized value, that means where the mean is 0 and the standard deviation is 1. We take away the mean, which will basically shift across graph across so that the mean becomes 0, and then we divide it by the standard deviation, and that will squash or stretch the graph, so again it matches up with the standard normal distribution, and this is our what we call our standardized value. So we can flip between a standard normal distribution and a non-standard one by using this little thing here, which you'll see up here. Yeah, so we can flip between the two, and you'll see later on how useful that is. So what we're going to do is we're going to find the area up to this value, but we're going to write it in terms of z. So let's start by drawing this diagram. I always draw a normal distribution and put in the values. So 50 is my mean, my variance is 4 squared, which means that my standard deviation is 4, and 53 is going to be over this side, and it says less than 53, so it's all about finding this area here in terms of z. Now we had that little formula from before, which is your z value is equal to your x value minus the mean divided by the standard deviation. And do take care, remember this down here, you need to put the standard deviation, not the variance. It's an easy mistake to make because we're given the variance as 4 squared, so don't put 4 squared down here, we're going to put 4. Right, so my z value is equal to my x value, which is 53, minus the mean, which is 50, divided by the standard deviation. So if I work that out, 53 minus 50 is 3, divided by 4, so it's 3/4, 0.75. So you could say like the equivalent z value, if this was 0 here, and this was 1 squared, and this was 1, the equivalent z value that will give you the same area, this would be 0.75. So they're like equivalents basically. It covers the same area. So in terms of phi of z, the area from the left up to z is the area from the left up to 0.75. So the equivalent in terms of z is an area up to 0.75. Okay, so that will be the answer for the first one. Yeah, so basically it's like an equivalent standard deviation, equivalent normal distribution, but with slightly different values. Okay, right. Let's have a look at next question, part B, and this time we still have 50 in the middle, and we have 55, which is over here, and it's about this area because it says greater than 55, and we want to write it in terms of z. So we need to work out what is the equivalent z value to this x value of 55. So again, the equivalent z value is equal to the z value, the x value that we have, which is 55, minus the mean, divided by the standard deviation. So that will give you 5 over 4, which is 1.25. So the equivalent Z value here would be 1.25. Okay, so the area up to this point as a Z value would be phi of 1.25. So that's the area of that bit. So what's the area of this bit? Well, the whole area adds up to 1. So the area of this bit that we're interested in is 1 minus the area up to 1.25. Okay, so that will be the answer to that bit there. Yeah, so we're writing it in terms of these Z values. And this phi of Z just means the area up to a Z value. And that little formula at the top tells us how to convert between an X value and a Z value. Right, let's have a look at this question here. Blood pressures are modelled by a normal distribution. It gives us the mean and the standard deviation. It's just written down here, so it's not how we would normally see it, not a problem. So basically we have, let's use X for this normal distribution, mean of 127, the standard deviation of 16. Right, that means the variance is 16 squared. So mean 127, variance 16 squared, standard deviation 16. So just write information. A medical researcher wants to study adults with blood pressures higher than the 95th percentile. Find the minimum blood pressure to be for an adult to be included in the survey. So again, a diagram makes it so much easier if you do a diagram. Right, so let's put that in. 127 here, and we know the standard deviation. And it says, it doesn't say a particular blood pressure, it just says the 95th percentile. Okay, but basically what that means is the area up to here needs to be 95%, 95th percentile, which means that the area over here is 5%. Yeah? Now we could work out that value using inverse normal distribution on our calculators, which is probably the easier way to do it. There is another way, and that's to use this standardise value. And the reason we would standardise it is because you'll see a table here. It's in the formula book. It's called a percentage points table. And basically what it does for a particular area, it gives you the Z value. For a particular area, it gives you the Z value. Now by area I also mean probability, so this P is like probability, it's the area. So probability or area. Okay, but confusingly, our calculators give us, will want the area from the left. This is the area going to the right tail, so it's a greater than. Yeah, so basically what it's doing is it's saying, okay, if this area here is 50% or 40% or 20%, I can tell you what the Z value is. So for example, if I were to take this value and look at the graph, it's basically saying, okay, this value here, right, this is 0.3, so it's just 30%. Notice it's on the other side, right tail, and it's telling us that the value of Z, this value here, is 0.5244. Yeah, it's useful if you quickly want to look up what we call percentage points, a percentage area. So a 30% area in the right tail its equivalent Z value is 0.5244, and you can see with the others as well, the percentage area in the right tail is getting smaller and smaller, which means in the left tail it's getting bigger and bigger and bigger. So by the time you get down to here, you've got down to something like 99.995% on the left. So if I wanted to find this area and this value, well, basically we know that this side is 0.7. So an area of 70% on the left hand side, the left tail, also would have the same value of Z. Yeah, so you could also say that the area up to 0.5244 is equal to 0.7. So this percentage points table is like the opposite way round to the thigh of Z function. Okay. Anyway, let's go back to the question. We're going to use this table to work out the answer. So we've been told that, well, we've got this 95th percentile. So this is 5% here. Now if I look at my percentage points table and look for 5%, I will find it. Let's just highlight it in a nice colour we can see here. That should be 5%. So this is saying when you've got 5% in the right tail, the Z value is 1.6449. So I'm going to write that down. 1.6449. Okay, that's what this Z value is. Now I want to convert that Z value to an X value. Yeah, so I know as a value of Z, that's what its value is, but I want to change that Z value into an X value. Now how do I do that? I use this. So the Z value is 1.6449. I want to find the X value, but I know the mean, 127, and I know the standard deviation is 16, not 16 squared. So I should be able to work that out. If I do 1.6449 and times it by 16 and then add 127, that will give me what X is. So let's just work that out. So menu 1 on a calculator, 1.6449 times by 16, add 127, and I get 153.3184. Right, so that's what that Z value is. That's what this value is here in terms of Z. So is that our final answer? Let's have a look. Well, it's asking about people who've got blood pressure higher than the 95th percentile. Well, the 95th percentile as a Z value is 1.6449. As an X value, it's 153.3184. So find the minimum blood pressure. Well, maybe it would make sense to give the answer as a whole number. So minimum blood pressure will be 153, what's in this whole number, mmHg, yeah? And that would be the answer to our question. Now I could just as easily have worked that question out by using inverse normal, yeah? So if I was doing that by inverse normal, I'd go to menu 7, I would do inverse normal, which is number 3. I will type in an area from the left of 95% or 0.95. I would use that standard deviation of 15 and a mean of 127. and I would get exactly the same answer, slightly different in terms of decimal places, but it would be 153.3177 to 4 decimal places, but it's pretty much the same. So this also could be done by using inverse normal, but if we notice, it's one of these percentages from the percentages point table, it just makes it a little bit easier, a bit quicker to do if you've got that table in front of you. Okay, you should now be in a position where you can do exercise 3D on page 49.